Good morning, everyone. It's a very, very nice Sunday. Oh, no, not Sunday. Sorry, Saturday morning.
Also not very nice. It's kind of rainy.
Here it's not raining. I don't know. I think we're 3 kilometers apart. Here it's not raining. There
Oh
it is
wow.
raining. So am I lucky? Yes, I am. And my shirt says, wait, Sunday? Yeah, so
But it's wrong.
it's wrong. Yeah, but I feel like Sunday. So yeah, so I'm happy to have you here, Annalisa. Again, you're our permanent guest. Maybe you'll
Ooh,
soon become not a guest, but a host. And actually, I
thank you
think
for
today,
having me.
yeah, and actually, I think today you are the host because
Am
today
I?
is the
Okay.
yeah. I mean, today the plan is to have a mock of an interview. So this is usually a part of some interview processes in big companies like Facebook and Google. So it's called ML system design. So the idea is that Annalisa will describe a use case for me, and then I will have to design a solution which will solve the problem of this use case, more or less. And yeah, I never experienced that kind of interview myself. Annalisa did, so
Yeah.
if you want to say about it a bit.
Usually it's part of a long process of many interviews. Um, and this is the interview in one of the interviews in which they try to understand, let's say, your reasoning skills and also how would you, in a applied problem in a real life scenario, solve a certain use case. And the key to these interviews is always to keep them, or I think it is, and my Google search tells me to keep them interactive. So just
Mhm.
not just start with a solution, but keep interacting with the interviewer. First, make sure you understood the problem, and then make sure you show your reasoning.
Mhm. Yeah, that's good advice. Yeah. Also, I heard some advices that you kind of have to be the main character of the whole process,
Mhm.
that you're gonna talk, and if you feel that you're interrupted too much, then maybe something goes wrong. Not sure how correct it is.
I think it's
But
better if you ask questions during, like, oh,
yeah,
is this assumption correct, or am I on the right track? Like, is there anything else I should think about?
yeah, yeah, I agree. Well, so I don't know.
Okay.
I forgot the part about our presentation, but I mean, probably people
Uh,
already know who we are, right? Or
Yeah, they know us.
uh,
Okay.
Annalisa is
So,
an amazing data in the eye specialist,
and eager
professional.
too.
Yeah, we all are, right?
We are. Always say we are.
Yeah, fake it till you make it. So that's what I'm about to do now. So I'm gonna fake the ML system design interview.
Okay, then let's start.
Yep.
So we have a
Oh
really,
wait, just
yeah.
maybe let's kind of limit it somehow. So
Okay.
maybe yeah. What about 45 minutes max?
hmm
So
Yeah.
let's say.
And
Okay.
this is usually also the duration of interviews, but considering introduction and the final words, maybe even a bit less, like 40 or so.
hmm Awesome.
Okay.
I'm ready.
So great. So this is the use case. So you work in a online dating company, and so let's assume Tinder just as an example, as a lot of people know how it works.
hmm
And someone in the company is noticing that in a specific area, so let's say Vienna, there is a higher churn than usual. And so churn is when users stop using the app, whatever
hmm
that might be. And so they want to understand different things. They would like to understand why users are churning, and they would also like to be able to identify the users that are about to churn before they do it. And if it is a problem that this user churn, then do something to prevent it.
hmm
So you need to design not only you need to design a system that says this problem, not only one time, but we would like to have a system that can answer to these questions like over a long period of time.
Yeah, well, sounds really interesting, and like this churn problem or issue is very popular in many companies, e-commerce companies mostly. So as I understand it, so we are Tinder and we have a lot of users. Every day they use our service, and then we somehow notice that some customer is not logging in for some time. And then we have to define this somehow, and then we call it churn. So let's not define it right now. So let's say the customer is not logging in for some time, and then we want to first understand why is this happening. Then we want to predict this in advance, and then we want to come up with some actions to kind of avoid it in the future. So it is correct?
Yeah, so this is the problem, but is the only possibility that the user stops logging in for a certain amount of time, or there could be other situations that you would consider as churn?
Yeah, right. So this is the problem, like the very first probably issue that we have to define what is churn. Because I think, yeah, we may come up with a couple of definitions. So I think the easiest will be, yes, so when the user is not logging in for, let's say, 2 weeks, that's like the very easiest baseline. But I think, yeah, we have to take into account that Tinder is like a specific domain. So it doesn't make sense for people to come back every day, because Tinder is made to find the right person. And if you keep coming back every day, so it probably means that you don't find the right person. But also here we have to take into account the business part of Tinder. So now I'm thinking that I think the first time, so how Tinder makes money. I haven't used it for a while. When I did use it, it was free. So I suggest that now they have some paid profiles, or maybe you can buy some tokens and you can increase the rating of your profile. Is this correct? Or there's also ads shown.
So I also haven't used it for a while, probably less than you. But from what I remember, I always had the free profile, and in the free profile there were some ads appearing sometimes. They look like profiles, but they were ads. And then there were other two ways of kind of paying. One, as you said, paid profiles, and they had some advantages like seeing who liked you already, or match with people that are in another country and so on. And then, if I remember correctly, you could buy boosters, like your profile is seen more, or you could buy super likes or stuff like that.
Oh, got it. Yeah. So basically, as I understand the business model of Tinder, it's either freemium, how it's called. So you register for free, but you're watching, you get impressed by the ads. Or you pay for your profile, and then you can you basically just buy a membership. So that's how Tinder gets money.
I would assume these two cases. Yes, I would leave the boosters and the tokens aside for now. It's a good assumption.
Okay, yeah. So I think if you put them aside, then it means that if I'm buying the membership, I'm usually buying it for maybe a month or a year, right? So, and I think this is the perfect use case for defining churn. But still, I want to take to have in my mind the first use case, so people who use it freemium. And so I'm thinking from the Tinder's perspective. So why is churn bad for them? So if people, I think that there should be some equilibrium point. So people kind of should get back to Tinder once in a while to keep using it, to like it. But they also shouldn't be there every day, because yes, Tinder will make more money, but in the long run, they will probably make less, because people will get frustrated that they cannot find anyone, and they will just give up, and this lifetime revenue will drop, I suppose.
Yeah, so it could be also that churn is kind of a positive thing. Sometimes, if one user leaves, maybe they found their love life.
Yeah, love of their life.
Their love of their life.
Yeah, and then they should pay Tinder for the rest of their life. Yeah, right. So I think it's probably time to somehow define the definition of churn. So yeah, it's a bit tough thing for me. So I suppose, well, I mean, for the second group of customers who buy membership, it's a bit easier. So if you do not prolong your membership, then it means you're churning. And yeah, I suppose for that kind of users, we would like to know the fact whether I'm prolonging or not quite in advance, maybe in 2 weeks or in a week before the previous membership ends.
We could focus on this case for now. Like, let's just assume the subscription users.
Yeah. Thank you for this. So okay, so we have subscription users, we have the membership, and then there is a moment when this membership comes to an end, and it would be nice for us to know it in advance. So let's say if we know it 2 weeks in advance, we could we could create some promotion actions for the users, or we can at first we can just ping them maybe and ask them, hey, are you gonna prolong your membership? Did you find the love of your life? If not, then please do it. Also here, yeah, there is this problem, I think in all the marketing or e-commerce companies, that there are customers who want to be pushed, and there are customers who don't like to be pushed. So I think we have to keep it in mind. So basically, if you send this promotion action to some people who are, I forgot this name, so they might be frustrated, and even if they wanted to prolong their membership, they won't do it just because you pushed them. And there's also another use case that people who will prolong their membership anyways, and probably you don't need to contact them because it's just a waste of your budget if it costs anything for you. So I suggest that any promotion costs money. So like at least for creating the text of the campaign or somehow contacting the people. So I would suggest that it does make sense to define, first of all, to define what customers to tackle with this. So I suggest, yeah, so I'm framing the whole problem in my mind. We want, sometime in advance, we want to know the group of the customers who we want to tackle. So,
and would this be all the customers that want to churn, or like should we, I don't know, leave some customers alone?
Yeah, so basically, I think, yeah, first of all, we have to define, yeah, what customers are about to churn, and then we have to, out of them, we have to pick the ones who will not be frustrated. No, actually, you're right. So this is kind of the tricky one. So yes, we have to define what customers will be churning. So our future model will predict the effect of churning, and the output of this model will be probability. So how likely is it that the customer will churn? And then we will have to make actions on some subset of the customers. So I suppose not on all the customers. So here will be the second part of the problem. So we'll have to define which customers to take and to pick and take actions. Yeah. So does it make sense, or do you?
Yes. But I would start by focusing on the first part then, like. Let's define churn, and let's define the problematic, the users that we define as churning. Like, let's not think about predicting now, but let's say there is a group of users and we want to define how many of these users have churned. How would we do that?
Yeah, so as long as we decided to go with a membership system, let's define churn as that the membership of the user is finished, and then the user didn't prolong this membership right away. So meaning that it finishes tonight, and then from the next day you don't have any membership. So this fact will mean that the user has churned. I think ideally, maybe in the real life, we have to introduce some buffer. So maybe if your membership ends on Monday and you usually act on weekends, then probably it does make sense for you to start the membership right away. maybe we have like to act in weeks. But just for simplification, let's say if your membership ended yesterday, then today you did churn if you did not prolong it. So with this definition, it looks pretty simple. Yeah. Just let me think. Maybe there are some caveats.
So would you switch like, is there some metric like of like inside of the users that churn? Could we define some sort of, I don't know, success metric, or
you mean the success metric of churning, or
yeah, like they could churn because they found the love of their life, or they could churn because they're
okay, this you mean this, okay, yeah. So why do they churn? Okay, so I just like want to finalize. So the fact of churning we defined. So now let's talk about why do they churn. So first of all, people could churn because they find it not helpful. So they tried it for a month. They maybe went for a couple of days, didn't like it, and said that, well, it's not my thing. Let's not use it. The next one could be, well, I kind of liked it, but I found the better app, and I want to, I forgot the word. So I want to stop using Tinder, but I want to use another app. And so the third use case will be that you found the love of your life and you're going to stop using it. And what else could be? What else could be? I think for now it's enough. So these 3 use cases.
Yes.
Yeah, and basically, I think you definitely have to act differently. So let's say we define churn. Now we have these 3 use cases, and based on these 3 use cases, we would like to understand our actions after when we were about to take them. So let's. I think it makes sense to talk about these actions right now, because if we won't come up with some reasonable actions, it doesn't make sense to build a model of churning. So let's say if I'm the customer who used Tinder for months, and now I just got bored. So I went on a couple of dates and I don't use it. So what can we do for this customer? Well, I think we can go even fancy and define like how bored the user got, but I think it will be overcomplication of it. So the easiest way will be just to maybe to send some how you say it, motivation letter to the customer, which will tell, well, hey, it's only the first month, keep going, you're doing great, and show some stats that you did 2 dates, and 2 dates is just 2 dates, so please keep going, and we're gonna assist you on the way. I'm not sure if it makes sense to offer some discount in this case, because the reason is not because the service is too expensive or so, but the reason is that they kind of find it boring. I think so. For the second use case, when people want to leave this app and go to another app, I think this is the case for some kind of a discount. So in this case, you can say that, well, we see that you used our app quite actively, but now you didn't prolong the subscription. So maybe you want to have this small discount of N%. So I'm not defining it now. So what do you think? Is it interesting for you? And for the third use case, when people just found their love of their life, I think we somehow could try to track it from the app. It's like another question, finding love of your life. If it's possible, that's a completely different task or solution or problem. If it's possible, then we can congratulate the person and tell them that we hope that this love lasts for some substantial part of their life. But if it doesn't, we're always here for you. No, I don't think that we have to say this. I think that for these use cases, we can just send them something really motivational, that we're happy for you, and maybe check out some other features of us. I don't know what these features might be, or check out some other companies that belong to the same business entity that Tinder has, something like this. But I don't see any actions on these customers. Will probably just frustrate them. So I think it makes sense to focus on these two groups. The first one, yeah. I'm thinking whether we can somehow distinguish between them. So is it just getting bored, or you don't like the app? I think for now, as a baseline, we can enter some metric like the engagement metric. So how often people use it, how many dates they had, how many times in a day they log in, and so on. So just see the activity of the customer. So if you see that they are engaged but they churn, that means that they probably want to try different apps. If you see that they are not engaged and they churn, then you probably want to motivate them, send them some lessons. I don't know how, like onboarding, like this is Tinder, it can do these things and this. Just try it, it's awesome. Yeah, so these two groups. Yeah, so I think this is kind of another task, defining these groups. Let's maybe come back to the first one. So defining the churn. Yeah. So now we approximately know what we're gonna do with this, and now we have to define people who are about to churn so that we can take actions for them. So first of all, I think it makes sense to define it a bit in advance. So let's say, I think a week in advance is okay, because for monthly subscription, a week is like 25% of the time. So let's say that 7 days before the month ends, we want to have the probability for the customers that they are about to leave. So,
okay, makes sense.
This is how our machine learning model task will look like. So for this, so this definitely looks like a classification task of machine learning model. And for this task, we will need some data. So first of all, let's see, let's put it on features and targets. So how are we gonna collect our targets? So this is, this use case is probably not too complicated in terms of target collection. We can look into the history of our of the user base and see. So basically, target one will be people who. So since we defined it 1 week in advance, then probably it makes sense for us to calculate this model only once a month. Yeah, let's say we focus on monthly subscriptions, and that means that we have to run this model only once a month, although it looks too simple for a service like Tinder. Yeah, let's say maybe subscriptions are like monthly, but they can start from any date. So that means that we have to run the model every day, and always run it only for the customers whose subscription is ending in 8 days, 8 or 7 days, depends on how long our model runs. So basically, as a historical data for the targets, we have to find all the customers whose subscription will end in 7 or 8 days, and as a target, we will put 0 as. So 1 will be churning, 0 will be not churning. So meaning that 1 will be the customers who did left in 8 days, didn't prolong their subscription, and 0 will be the ones who did prolong their subscription. Right, and also, so these 7 days in advance, we don't have this information whether they are prolonging for the next months, because sometimes people buy like half a year, and this is not our case. So we have to filter out this kind of customers. So only the customers who have 7 days left, and we don't know for sure what they're gonna do. So this will be our target. And for features, the predictors, let's see, what do we have? We have, first of all, the social demographic information about the customer. So basically their name, their gender, their age, location, maybe some interests. I think there is, I think you can input a lot of data about yourself, maybe even pick some categories of interests, or maybe it's just free text. Then we're gonna use some NLP approaches, or we could use. We have the photos. We have probably the connection to some social media services. At least when I did use, you had to provide your Facebook ID. What else we have about the customer social dem? Yeah, I think it might be enough for now. Also, we have the historical activity of the customer. So we know how many times did they log in, how many dates they had, how many likes they did, dislikes, and so on. I mean,
We don't know how many dates they had.
it's a secret in Tinder. Okay, I didn't know it.
Well, it could be.
Yeah. I mean, it's up to the dialogue. Yeah. So I mean, we know how many matches they had and how many times they initiated the dialogue between the people, and also probably we can also measure the duration and the length of this dialogue. And yeah, probably GDPR, we cannot know what is in the dialogue, and let's don't think about it. So yeah, basically engagement, how many times they liked, disliked, used super likes, or how it's named. Yeah, whether they use all of their free likes if it's a free user. So basically all possible counters that we can come up with. And it could be like counters, it could be averages for the last week, for the last months, for the last half a year. Basically, I would probably in the first time I will come up with all possible counters, take the amount, the average, probably the median, some quantiles, and so all possible features I can come up with. And also, I think it makes sense to somehow, yeah, maybe we can take a look at the users that our customer engaged with, if it's possible. I'm not sure if Tinder allows us. Probably yes. Or probably we can know what customers we started talking with, and we can somehow get their features. But I would say that for a baseline, we don't really need it. Let's keep it apart. So let's say,
Let's keep it inside.
Yeah, so we have social demographic features and we have the historical activity.
Makes sense.
Yeah. Also, it makes sense to introduce some context features, like what this current season it is, like to basically if it's winter and it's super cold, then probably the activity will be low. Also, the geographical location, some kind of this, right, the days of the week and so on. So yeah, we have these three groups of features. We have the target. Basically, now we have to pick the model that you want to train. Of course, I would like to start always from very easy models. So let's say we will build a small linear regression or logistic regression model, sorry, which is linear, yes, and I think it will output us some fancy results. So now we have to think of how we're going to evaluate this model. So first of all, we have to evaluate the model itself. It's going to be some technical metric. But when we will think about the whole use case, our technical metric is not really relevant. So we would like to validate some business metric. And what could it be? Actually, maybe for the problem of churn, it's not the case. So what do we want to know? We want to know how good our model is predicting. On the historical data will be historical data that will be our technical metric, let's say. Then we would like to know how it works in reality. So when we will put this model into production and see how it works, and in 7 days we will know which customers will churn, which will not. So in this amount of time, we will be able to evaluate it. This will be our real technical metric. I'm not sure if it makes sense to connect this model to the revenue that Tinder is making, because it's probably not that easy. If you want, we probably can see how much money we are saving for the company. I think it does make sense to really
so I mean, there could be something one customer is bringing more money than others for the lifetime value, but let's keep it simple that that this is constant. So the cost of losing each user is the same.
Yeah, that makes sense. I mean, also we can think of this, how much money the user will bring, how much money the promotion costs as well. This we might take into account. And because if we would like to, also I think our model might differ based on our actions, because if we would like to run our possible promotions on the whole data set of the users, then, for example, our metric might be something like area under the curve. which will show how good our classificator works, classifying zeros from ones. But if you want to focus on, I don't know, top 100,000 of users, it take only them and send the promotion material to them, then we might pick a different metric, something like lift. So how good our model is predicting the top 1,000, not all the population of the customers. And I think since we are doing the promotions, this is the case. So we care about how our classificator is good for the top population of our whole population. Yeah.
How would you define the top population?
This is question. Yeah. So we have probably. I'm not sure if we have to define it now. Yeah. Let's say if we. I'm just thinking out loud. So if we have one. You said Vienna, right, in the very beginning, right?
Yes.
So so that means probably in Vienna we have, I don't know, 50,000 user probably. I'm just thinking out loud. And maybe our candidates whose subscription is about to end every day. Well, yeah, let's see if all of them have monthly subscriptions, then probably every day there is quite a few of them who might be our candidates. Yeah, I would say that will be really a few. So around 1,000, like the magnitude of 1,000. Yeah, then in this case, it probably makes sense to run it for all of the customers and not to split it on the top and not top. Because yeah, I mean, if we defined only 1,000, then we can take actions on all of them. Yeah, so then my idea with lift metric is probably not worth it.
No, I don't know. Maybe it is. I'm just thinking out loud too.
Yeah. So yeah, I would say that if it's only 1,000 customers, then probably we could say that we either send the promotion to all of them or we try to pick 100 out of them who are the most promising. But here we have to define like how much the customer will probably bring us next month if we get them back, or how much money we will lose if, for example, they get frustrated from our promotion, and also how much money we lose on the promotion itself.
Yeah, so just in the interest of time, let's keep it simple. They all cost the same. So
okay, yeah. So you already said it before. Yeah, right. So let's say we're gonna run it for the 1,000 of users, and I would pick the metric of area under the curve. So this metric will first of all, it's independent on how imbalanced the data set is, and our data set will be probably imbalanced because I hope that most of the customers will not churn. So maybe it will be like something 10 to 90. Yeah, and then so this metric it is not dependent on the threshold that we pick. So where we put the border of what's 0, what's 1. And in this use case, we don't even have to do that. So basically, I would pick this render curve, and I will start from easy models, as I said, logistic regression. Then I would see how different, more complicated models work here. So it could be trees, it could be boosted trees. If we have some features like images or NLP, we probably will use embeddings. So if you want to convert images to some numbers or texts, then it might make sense to use some deep learning models because it's just easier to combine non-structured data with structured data. Another way will be, so yeah, I'm not sure how deep I should go here. We can, of course, not use deep learning if we don't want. Basically, I would say that we have to experiment with all of them. And so basically, we will have the historical area under the curve for all of these models. Then we have to pick one of them, and probably that will be our candidate to be put in the production. So yeah, so here I have to say that our problem is something that we will solve with batch approach. So we don't have to have our model online running always, because we don't have to know predictions always. It's just like once in a day. It means we don't have to worry a lot about latency and how our model is served. So basically, it have to be served. Yeah, so once in a day we collect these features, we calculate them, then we send them to the model. It gives us the predictions.
It gives you a probability, right?
Yeah, it gives us the probabilities. Yeah. And then based on these probabilities, we can act. So basically we have 1,000 customers, we can sort them and start acting from the top. But if it's only 1,000, we can probably send these letters for all of them. So now we know, basically now we know what the customers, how the customers are about to churn, and then it's a question of distinguishing between the types of the customers. So is it the bored customer? Is it the customer who wants to try a different app? Or is it the customer who found the love of their life? And this is the moment when we have to distinguish these three use cases. And probably there should be another model or just a simple analytical approach how to distinguish it. I'm not sure if we have to dive into this area now.
So just so you have a no, we don't have to,
Mhm.
but we have a probability, and how would you say based on the probability if we are predicting the customer to churn or not?
Mhm. Yeah, basically, I probably even so this knowledge we need only to you're right, yeah, so we have to somehow to set some threshold, yeah, to define which customers we would like to contact. Yeah, okay, so we have 1,000 customers and we will have 1,000 probabilities, and now we have to put this threshold somewhere to not contact the guys who are below this, who are not about to churn, and to tackle only the ones who are above. So yeah, here we probably have to take into account this customer lifetime value, first of all, then second, the cost of the promotion, and also here probably we have to somehow find people who will be frustrated by our promotion. And yeah, so I mean, I'm jumping to a kind of different tasks. So we have 4 groups of people who are about to churn, and don't want to be contacted, who are about to churn and want to be contacted, and who are not about to churn, who don't want to be contacted, and who are about to churn, not about to churn. Well, you understand me. So, and basically we have to pick the group that is about to churn and is okay to be contacted.
But
I
we need
think
to
it's,
define it, right? Like we need to say,
yeah,
okay, this is about the churn.
yeah, but yeah, it kind of brings us to a bit more complicated task because it's not just defining churn, but also defining these groups. Yeah.
But let's assume we wanted, even before deploying the model, we wanted already to decide this threshold.
Okay, yeah. So
what could be an approach for that?
yeah, so I would say that an approach for us could be looking at the previous data, yeah, and creating some simple equation of let's say on the plus side we put the money that we might make with this customer. So, and on the minus side, the amount of money that we will lose. Yeah, that's a bit too easy. So we make a lifetime value for the customers, and we lose lifetime value for the churn customers, and also we lose the amount of promotion. And yeah,
I was thinking like much simpler in the terms, for example, of precision and recall. Like,
yeah, I mean, if we just go into precision recall, yeah, so we
it's much
our,
simpler. But
yeah, I agree. I mean, okay, so we have this probabilities, and we can always jump into this binary metrics like accuracy, precision, and recall. Accuracy doesn't make sense in this case as it's imbalanced. And now we have to define, yeah, what's more important for us, like first type of error and second type of error. And here I think, what do I think? So let's hope that our customers are not really super angry and they won't be scared away if we contact them with some promotion. Yeah, and let's see that we want to contact more people who are about to churn, and we're okay to touch the people who are probably not about to churn anyways. So that means we want to increase our precision. So out of all the customers who might churn, we want to kind of find as max of them as we could. So that means
isn't that recall? But I'm bad with this.
No, recall, I think it's out of all our precisions, we want all of them to be kind of true. So, and I think precision means that you want to find all ones, but recall means that out of all predicted ones, you want many real ones.
I think it's the opposite, but we can look it up later.
Okay,
and maybe
yeah.
you're right because I'm bad at this. But yes, please keep going.
Yeah, so I think it's precision that we want. So basically, we want to maximize precision, but of course, we can maximize it just putting the threshold to 0, which is a bit useless. And we probably have to, I mean, there are a couple of ways. You can look at some formula like F score, F1 score, F2 score, and so on. Or you can look at the graphs of how precision and recall are changing when you change the threshold. And we have to find some point when we are pretty happy with our recall and we are super happy with our precision. So I would say that, yeah, I'm not sure, probably we have to automate it somehow, but I'm not sure if, yeah, so if you want to automate it, then I will probably go with some kind of a precision recall area in the curve metric. So, and I would say that based on historical results, I want it to be not less than X, because for now I cannot say how it could be, because it could be like really different. I can evaluate it for area under the curve, like ROC area under the curve. We want to have something like from 70 to 90%, but for precision recall area under the curve, we might have even 5%, and it will be good. So I would say we look at the previous results and we want to be around them. Or we say that we want precision at least 95%, and then we'll probably say that at the same time our recall should not be less than 50%, and then if it's less, then we slightly increase the threshold and our recall will get to 50, precision will drop, but it's okay for us.
Okay, so in the interest of time, so let's say now we have defined, basically we have defined what churn is, we have we have decided which data we want to collect, how we train our model. We also touched on how you deploy your model. And now so now that we have deployed our model and basically we're batch scoring every day, we said, right?
So now, so we're scoring it every day, and we also have to evaluate it probably every day, if that's the way you want to go. Or if, I mean, also we have some KPIs, like technical KPIs that we're tracking, and also we have like the real world KPIs that we want to track. So meaning 7 days after the model is trained and applied, we want to see the real churn. And here we will collect the historical data, and we will be able to evaluate how good the 7 days back model was. That's how we can track our tests. So because, for example, we have always one model in production, and we would like to maybe test one of them, or like improve this model and see whether it's better than the previous ones. So some kind of an A/B test. Yeah, it's like another rabbit hole if you want to jump into this.
No, just summarizing, what would we do now? Like, so now we have our model into production, and
yeah, so now
what do we do with it?
Yeah, now we have this model into production.
From the technical point of view, not from the interactions with the user.
From the technical point of view, yeah. So basically, we have to, first of all, we have to, we train it, we deploy it. So we don't even have to deploy it. I would say I would probably won't deploy it. So we train it, we do predictions right away. We save these predictions to the database, and the model, we can save the model artifact, but it's not really important for now. So we have these predictions, and we can put them to some SQL database or some data lake. And then some other process will get to this database, pick the customers that we want, so which we already probably defined based on our precision recall equilibrium. And they will pick these users, and given the fact what type of users it is, they will send some specific promotion material. So ideally, we already have to know what type of users they are.
And then how often would you like decide if you want to retrain the model?
Yeah, that's a good question. So I would say it's up to experimentation. There is no right answer. So I would, like, it depends on if we're just starting this churning model or it's already a churning model which runs like for many years and we're just polishing it. I would probably retrain it somehow once in a week or once in a month and see how it goes. But at the same moment, I will always try to change this horizon. Let's say try to retrain it every 3 days, and I will have these two models always, and we'll run an A/B test between them and see how our results are changing with time. Also, I'm thinking whether there is some kind of positive feedback. So meaning that if we predicting so far some customers, if we have some engagements and our model thinks that these engagements to lead to the churn, and then we send them a churning promotion, anti-churning promotion, then they act upon it, then they do the same engagement activity. So it's like, yeah, so there might be some kind of positive feedback loop, or might not be. No, probably it's not this use case, so it's going to be okay. So not in this use case. Yeah, so I would say I'd start from retraining this model once in 7 days or a month and see how it goes, and then I would experiment with different horizons. I mean, also there are a lot of parameters in the model, so how far in the history we would like to look to get our features. Yeah, I'm kind of I was talking too much, and Elisa got bored, and hopefully she gets back in a couple of minutes. Yeah, let's maybe wrap it up. So I think I won't tell you anything new, so maybe you could say a couple of words how bad I was, and we can get from there.
So I guess at the end, I could ask you if you have any question for me.
Yeah.
Or like any feedback or any question for me.
Yeah, I mean, of course, I will be interested in the story that I kind of tried to tell, because now I understand that it wasn't really a story. I was jumping from one thing to another. I tried to define the business problem first and then keep it constant, but I was always getting back to it and thinking twice whether it's what we want to solve or not. So this is what I'm unhappy with. Yeah, and yeah, I mean, also the for me the main problem was whether I should go into this direction or not. Like whether it is the model that I want to tackle, whether we should define these angry customers, not angry customers, what type of customers, how to define between them. So it's like it's always the possibilities to jump into this rabbit hole, and I did not restrain myself. So
yeah, I think I'm hearing my echo, but I think you don't hear it. Okay, that's perfect. So I think from at the beginning we could have both defined the model, the problem better. Yeah, but also from my point of view, I could have guided you into defining the like one problem, one subset of the problem, and just go with it.
Yeah, but yeah, it's also a nice thing for me, probably for the future, because any problem has adjacent problems, and you have to focus. Yeah, and how was it in terms of machine learning part itself? Do we have to touch something else besides the set of features, the type of the model?
No, I think you defined the data collection well, and the type of model. I mean, not having the data is hard to say what model it would be better to use. So I guess an interviewer could give you this information, could tell you how unbalanced is the data set, but you touched on it, or that maybe we expect a small subset of the feature to be relevant, and then one could build on that. But in this case, I didn't give any indication in this direction, so I think it was okay. Also, it's the first time I do this, so I don't know. Clearly, a professional interviewer can direct you better, right?
Yeah, probably.
And regarding the modeling, which is like my favorite part, obviously, I think I would in general start much easier and then build upon the easy. Like for example, defining the area under the curve and then saying, okay, then we need to decide the threshold and like
Mm-hmm.
and go from there if we need to define a cost function or something like that.
Mm-hmm. Yeah, you're right. Yeah, because yeah, I was just thinking about this area under the curve metric to evaluate the model, but I didn't think what's the next step. Yeah, when we need the threshold. Good. Yeah, I already said it when I was alone. I really got nervous. So
Yeah,
even
I
if it's
noticed that
a
a
mock
bit.
interview, but it's pretty complicated. So now I have to breathe. Well, yeah. Thanks a lot, Annalisa.
No,
That's an
thank
amazing
you. Thank you
experience
for
for me.
having me.
Yeah, and yeah,
And
hopefully
sorry
we
for the
can.
technical issues.
And no worries. I think that's completely perfect. So I think we might do it a bit more. At least I liked it,
Hmm.
and I want to improve.
Hmm.
Let's see.
We can also do the other way, maybe.
Yeah, we could also do the other way. So yeah, well, thanks a lot again, and thanks a lot for who chose this video to watch it. Maybe not right now, but in the future. And we hope that you will come back to our channel and subscribe. So yeah, have a nice Saturday, Annalisa, and
You
cheers
too.
to everyone. Yeah,
Bye.
bye bye.